Hi, this is Jeff Spencer, Math 120 instructor for the Community College Denver, and this is a video lecture over the applications of linear equations or linear models. This comes from section 6.3 of the old book that I used, and so we're going to be looking at problems that fit a linear model and creating an equation for that to solve the problem, or creating the equation and then using that equation to solve the problem or various situations from that model. In case you're wondering what a linear equation is, in algebra class this is taught this way. The formal linear equation in like an algebra class is that y equals mx plus b. So maybe you've seen that before, but m is supposed to represent the slope and b is supposed to represent the y-intercept. And it's true here too. Let me put this up here. Is that the y value is based off of particular x values. So each y value depends. Sometimes we call y the dependent variable and x the independent variable. And so x can kind of change. It like changes. It could be time or something like that. This could be like the number of hours that somebody works, or the number of times somebody does something. And then y, it changes based on the value of x. Now there's two other factors that determine y. It's the slope and the y-intercept. Visually, a linear equation looks like one of these graphs that you see here. I've just pulled this up on Google. So something like this. This shows a linear equation with a y-intercept of 3 and a slope of -4/5. And you can see that for each y value, which is on the y-axis, for each x value, there's a unique y value. And so these are all different kinds of linear equations. The slope of the line is kind of the angle of the line. Negative slope is when the line goes down. Positive slope is when the line goes up to the right. And so these are the graphs of these equations, just so you're familiar with that. But we're not going to be graphing this stuff. We're just going to write the equation and then solve the problem. However, for this class, since this is more an applied class and not really an algebra class, I'm going to kind of aim for this less formal model when I do this. So what I'm going to do is, instead of the y-intercept being at the end of this equation, I'm going to put it at the front and call it the starting amount. So y still depends on x, and these are variables that are dependent on the problem, what y and x are. So x could be the number of hours that you work and y is the pay, or x is the number of sales that you do and y is, say, your profit or something like that. So y and x are really dependent. Those variables are dependent on the situation of the problem. But there should always be a starting amount, which in the formal equation is the y-intercept. And then the slope is a rate. It's a rate of change. So it'll be like dollars per hour or dollars per sale or something like that. So I'm going to write my models for each of these my linear models, using this kind of format because I think it's more communicable and just easy to understand. Now notice the rate could be positive or negative, so I wrote a plus or minus here because we could be losing things or gaining things depending on if the rate is positive or negative. So we'll see a situation, both of those situations in these examples below. So let's look at this first one. It says a particular company offers a moving truck rental for a $100 flat fee plus $15 per hour. So the model of this is clearly the cost is dependent on how many hours you rent this truck, right? So cost is going to be my dependent variable y, and the cost starts off at $100. That's the flat fee. That's the starting amount. You got to pay that no matter what. So that's my starting amount. And then I have to pay more, $15 for every hour. So notice I'm not putting y and x. I'm actually putting in the actual variables that are in this problem because I think it's easier to write it that way. I mean, I could write y equals 15x plus 100. I'll write it down if that helps too, and that makes sense. That's great. That's the same thing as this. It's just the one on the left is less formal and more kind of related to the problem directly, and this is just a more formal way of writing it. So the cost is we got to pay $100 up front and we got to pay $15 for every hour. So that's why we do 15 times the number of hours. So this is the model here. and then I'm going to use this model, this equation, to answer these various questions. So it says if you have $200, what is the maximum number of hours you can rent the truck for? So in this problem, I'm trying to figure out the hours, and I know that I can spend $200. So 200 is my max, so that's the cost that I can spend. That's the most that I can spend, equals 100 plus 15. And now, I mean, I could write hours here, but now since I don't know the hours, I'm just going to call it X. Put the variable in there. Okay, so now I got to solve this equation. And to do this, it's going to be two steps. The first step is to subtract 100 from both sides of the equation. So minus 100, minus 100. That cancels the 100 on the right. And then it gives me 200 minus 100 is 100 equals 15 times X. The next step to isolate for X is to divide by 15. So I'm going to divide by 15, divide by 15, and I'll get X equals 100 divided by 15. Oh, my calculator froze. Okay, so 100 divided by 15. So 6.6 repeating. 6.666666 hours. All right, now I have to think about this. All right, so if they're going to charge me $15 per hour, and this is the maximum number of hours that I can rent it for, my final answer is actually going to be 6 hours, because that's the maximum. If I can only, my budget is 200. If I rent it for 7 hours, then it's going to cost me more than 200. So my answer here is going to be 6 hours. I have to use the logic of the situation here. The maximum is 6 hours, because if I rent it for 7 hours, it's going to cost me more than 200. So 6 hours is the most I can rent it for. Now, if they are down to charge for a partial hour, then yeah, I can rent it out for 6 2/3 hours. But usually companies don't do that. They charge you the $15 for, even if you rent it for an extra minute, they're going to charge you that for that hour. So 6 hours is the maximum number of hours. Okay. Part B. If you rent the truck for 11 hours, how much will the rental cost? Well, this will just be, now I'm trying to figure out the cost if I know the number of hours. So I'm just going to plug in 100 plus 15 times 11. So let's do that. 100 plus 15 times 11. $265. So there was no solving there. This is really just plugging in the number of hours and figuring out the rental costs. Okay, next example. Let's see here. Each person, or sorry, not each person, a person weighs 246 pounds and starts a regimen to lose 4.5 pounds per week. So the weight depends on how long they've been on this regimen, the weeks. So I'm going to say weight, that depends, that's my Y value. Weight is equal to the starting amount of 246. Now I have a negative rate because I'm losing 4.5 pounds for every week. All right, so the rate is negative 4.5. That's per every week. The starting amount is 246. So there's my format there. If you wanted to write this in very formal y equals mx plus b, this would be y equals negative 4.5 times x plus 246. All right, then, if it says if you did the regimen for 2 months, which I'm just going to assume is 8 weeks for simplicity here, what will this person's weight be? So I know the number of weeks now, and I'm going to figure out the weight. So I do weight equals 246 minus 4.5 times 8 weeks. So I plug that in. 246 minus 4.5 times 8. And a person's weight will be 210 pounds. Okay, so that's the final answer there. This one says, how many weeks would it take to reach 200 pounds? Let's say that was the goal that this person's going for. So 200 pounds, I know the weight this time, so I plug that in on the left. And now I need to solve for the number of weeks. So I do 246 minus 4.5 times the number of weeks. All right, so to solve this, I subtract 246 from both sides. And I get negative 46 equals negative 4.5 times x. Then I divide both sides by negative 4.5. And I get x equals, so I got to do 46, negative 46 divided by negative 4.5. The negatives cancel, so I didn't necessarily have to type them both in there, but whatever. And it's 10.2 weeks. Now, this particular problem, can you have 0.2 of a week? Yeah. And there's no specific requirement, so you could say about 10 weeks or 10 to 11 weeks. 10.2 weeks is fine too. All right, then the last example is a little bit more complicated where we actually have two linear models and we're going to set them equal to each other. So we're going to have two of these linear models, starting amount plus or minus the rate times x, and we're going to set them equal to each other. So on eastbound I-70, there's an option to take the express lane for $15 each day. However, you can buy a monthly pass for $40, which makes the cost of the express lane $7 each day. How many days would you need to use the express lane to make the monthly pass worth it? So worth it just means like if basically you want to make your $40, you want to basically save enough. So if you're saving $8 each time you use it, you want to make sure that you save at least $40 by using it. So here's the way I'm going to look at this. I'm going to do the non-monthly pass plan. And I'm going to set that equal to the monthly pass plan. Okay? So there's really two models. The non-monthly pass, there is no starting amount. The cost is just equal to 15 times the number of days that I use the pass. Let me set them equal to each other here in a minute. I'm just going to show both of these here. All right, then over here, the monthly pass, the cost equals the starting amount of $40 plus the $15 that I do, or sorry, the $7, excuse me, the $7 that I take the express lane each day. Okay, so notice over here the cost doesn't have a starting amount. You just got to pay $15 each day that you use it. And over here the cost, you pay $40 up front, but now it's $7 per day. And so what I want to know is basically when these things are equal. That's what we mean by like how much when it's worth it, right? So these are both costs, so I'm just going to set them equal to each other. So what I'm going to do is I want to know the number of days, so I'm going to replace that with x. I'm going to do 15 times x, that's the left plan, equal to the right plan of 40 plus 7 times x. All right, now what's different about this equation versus the previous ones is that x is on both sides of the equation. That did not happen on either of these ones because all of these, it was just a number on the left and then x on the right, so we had those steps to solve that equation. This, the first step is different. We got to get x on one side of the equation. So the first thing I'm going to do is move this 7x over to the left-hand side. The way I'm going to do that is subtract it over. So minus 7x on the left-hand side and minus 7x on the right-hand side. So that so I move it away from the right-hand side over to the left-hand side. So 15x minus 7x is 8x. And that equals $40. Now what's cool about this equation is remember, if I pay the $40 up front, then I save $8 each day that I use the express lane, right? And that's exactly what this is showing. I want to know how many days it takes saving $8 each time to basically pay back my $40 that I paid up front. So the way I solve this, I divide both sides by 8. Divide both sides by 8. Turns out that the number of days is 5 days. So in other words, 5 days to make it worth it. And the key thing is that if you use the express lane more than 5 days in a month, then you should definitely buy the pass, because at that point you'll be saving $8 each time. However, if you know you're just going to go up, say, 2 times in a month, then you shouldn't buy the pass because you're paying the 40 up front and you're not saving enough to make it worth it. So that's it for these examples. We'll see you next time.